Now, except for some really, really weird graphs that you might learn about way later on, um, for our purposes, at least a right or left hand limit should exist at any point on the graph, except for some very strange examples. Now, what we would really like, instead of just a right or left handed limit, is we'd like something called a general limit, which is a stronger condition. So, a general limit is when both the right and left hand limits exist and that they're equal to each other. So, to think of this, imagine if you had a nature trail and you have somebody starting at the end of the trail and hiking towards the beginning, and you have somebody starting at the beginning of the trail and hiking towards the end. It would be very, very alarming if each person hiked halfway through the trail and they said, "Okay, where are you?" And the other person says, "Well, where are you? I don't see you either." So if the trail didn't meet in the middle, there would be like this gap in the middle where who knows where you go. So you definitely want a general limit to exist most of the time. So mathematically speaking, if your right hand limit equals your left hand limit, then your general limit does exist and equals that same right and left hand limit. Now, if your right hand limit does not equal your left hand limit, or one of them doesn't exist, then your general limit does not exist at that point. So let's check out and see what that means here. So these are just some situations where general limits may not exist. Certain areas of piecewise functions might not have limits at certain values. So remember that when you have maybe a graph that's kind of discombobulated. So you might not have a general limit like at this value of x. Any jumps or breaks in the graph, which is illustrated again right here. There's a pretty big jump in the graph right there where looks like we're headed towards here at this point, but we are actually down at that point. Anything where you have an asymptote, and our general limits still can exist at asymptotes. So sometimes they do. So like here, we're headed towards negative infinity on both sides of the graph here. But, we still can't plug in that value in the middle, but the general limit would still exist because we're headed towards the same place. Now, if we had something like our 1 over x graph, where on one side of 0, we are headed up towards positive infinity, and then down here we are headed down towards negative infinity, we would not have a general limit at 0. So if I wanted to write, like, what's the limit as x goes to 0 of 1 over x, that does not exist. And look at the very slight difference in notation here. If we're looking at a general limit, then we are looking at just the function value, and notice that it doesn't have a plus or minus sign right there. So that's when we're looking for the general limit. Sometimes they exist, sometimes they don't. Now, holes in your graph can be a bit of a problem, but in terms of limit, they're actually not that big of a problem. So we'll take a look at that here in a sec. So let's take a look at this graph right here and see if we can determine any of these limit values. So we start off here with the limit of f of x as x goes to 4 from the right. Okay. So best thing to do is just get on your graph here, and you're following your function along as x is getting closer and closer to 4. So remember, your x getting closer and closer to 4, that's a horizontal measurement. We're not talking about like the function going to 4. So as x goes to 4, our function is shooting up towards positive infinity right there. And then as x goes to 4 from the left, again, we're just kind of following and seeing what our function does. And that is also going up towards positive infinity. So since both of these values are the same, there we go. So we're going to infinity from the right and from the left. Then we would say that that general limit exists and is equal to infinity. Now let's head on over to -4. So for our first one here, which is x going to -4 from the right, so if you go on your line here and you follow along your x values, we are headed towards the value of 1. But if you go at it from the other direction, so you're following along, so we're looking at x going to -4 from the, I got these mixed around a little bit. So this first value that I found here, that should be x going to -4 from the right. So this is actually right here. So as x goes to -4 from the right, we're going towards the y value of -1. And then as x goes to -4 from the left, which is the first one that we did, so that would be these values right over here, our function is headed towards +1. So on our graph, from the right, we're going down to -1. From the left, we're going to +1. So that means that this limit, unfortunately, does not exist. We're going to two different places, so the general limit, no good. And then let's check out this table here. So if you just have values on a table, sure, it might be possible that maybe we didn't use enough table values, and maybe 3.99 is where things really start to kick off with our function and it does a bunch of crazy stuff. But we've got the values that we've got on our table. We don't have any more. So we have to make kind of a hypothesis about what our function is doing based off the information that we have. So if you look at the values, if we start by plugging in 3.8, our function is at a little bit more than 128. And then if we plug in 3.9, so a little bit closer to 4 here, our function is at 567.2. And then when we get really close to 4 and we plug in 3.99 in for x, we're at, 5,700. So we're going up, and then we're really going up. So we would have a lot of evidence to say that the limit as x goes to 4 from the left, which remember means that we're looking at values of x that are less than 4 of f of x, would equal infinity. It's just going up and up and up some more, and we can't really say too much else about it. Now, if we wanted to look at the limit of f of x as x goes to 4 from the right, then let's take a look at what happens there. So at 4.2, and for these values here, we're using values that are pretty close to 4 if we want to talk about what the value of the function is at 4. So we're not starting at like 10 and working our way to 9 and then 8. We're starting relatively close to 4. So at 4.2, if we plug that into our function, we get 6.1. Okay, so let's get a little bit more information. we plug in 4.1 and we're at 5.24. So we're decreasing, but just a little bit. And then as we get even closer to 4 at 4.01, we're really, really close to 5. So this behavior is a little bit different. We're going from 6.1 to 5.2 to 5.00. You would have plenty of justification to say that the limit of f of x as x goes to 4 from the right is equal to 5. So as x goes to that value, which means that we're looking at values of x that are greater than 4, our function f of x is just inching closer and closer and closer to 5. Now, since the left-hand limit is not equal to the right-hand limit, the general limit, so the just limit as x goes to 4 of f of x, does not exist. All right, now we're making some progress.